So if we remember from the previous lesson, when we talked about stacks, a stack had 5 basic operations. It had a push, which means add to the top of the stack. It had a pop, which means remove and return the top item of the stack. It had top, which means look at the top item of the stack, return the value. It had size, which returned the number of current items on the stack, and it had is empty, which just returned a true or false. True if the stack did not have a size of 0. If it did have a size of 0. A queue also has 5 basic operations. And in fact, they're pretty much exactly the same, but the way they're actually implemented is a little different because of the LIFO versus FIFO order. So instead of push, we use the term on queue. E-N-Q-U-E-U-E, on queue. The opposite of on queue would be DQ, not Dairy Queen. So on queue and DQ essentially means push and pop. So before we go into this any further, let's think about how that would work. In an array, for a stack, when you push, you just added it to the next index of the array. For a queue, you can do the exact same thing, but you have to visualize it a little differently, because in a stack, the next index of the array represented the top of the stack. For a queue, the next index of the array represents the back of the queue. Because as we know, when an item gets removed from a queue, it comes from the front of the queue. That would mean that index 0 would be removed from the queue and everything would have to be shifted. Alternatively, you could think of it the other way, and every time you add, you shift one in. But it's easier to only do the shifting on DQs. So think of it like this. The front of a queue is always element 0. The top of a stack is always the last element in use. So when we want to on queue, we're always adding to the next item in the array. And we want to DQ, we're always removing item 0. Now, when you think about this, if you're doing this as a linked list, that makes your life really easy. There's no shifting involved. You don't have to shift any array items or anything like that. All you have to do is manipulate the next values of each element or each node of the linked list. So instead of top, queue has peak. It really means the same thing. It means return the value that's currently which is currently at the front of the queue. Not at the back of the queue, the front of the queue. Size, which does the exact same thing, returns the number of items in a queue, and of course is empty, which returns true if there are no items in the queue currently. So as you can see, a stack and a queue are really the same things. It's just the way we visualize and interpret how it interacts with one another, which creates this abstract concept. Stack works from the bottom up, queue works from the front back. Simple as that.